1 mole is the amount of substance that contains as many particles as there in 12 gram of carbon-12 isotope. How can you represent 1 mole in terms of molar mass? Yes, 1 mole will be equal to 1 gram atomic mass. Simplest whole number ratio, various atoms present in a compound. What is that? Empirical formula, right? Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So today we are beginning with the session 4 of your chapter, Some Basic Concepts of Chemistry. Yes, so in last class we had discussed about the laws of chemical combination, under which we studied 5 laws. Those were laws of conservation of mass, laws of definite proportion, law of multiple proportion, Gay-Lussac's law of gaseous volume, and Avogadro's law. Yes, and then afterwards we studied about Dalton's atomic theory and its limitations. Yes, and we even discussed about atomic mass, average atomic mass, molecular mass, and formula mass. Yes, so in today's class we will be discussing on mole concept, then we'll be discussing on molar mass, percentage composition, empirical, and molecular formula. Yes, so let's not waste time and begin with our first concept, that is mole concept. So I hope you remember when we were discussing about the SI system, the units which are considered in the SI system, we studied about 7 base units, right? So under the amount of substance, the physical quantity, amount of substance, we studied that the SI unit for it is moles, right? So at that time I had told you that we will be discussing on it in detail, right? So now in here we will be studying about that. So what is a mole? Right? So we are going to study about that. So before beginning with what is a mole or mole concept, so when you go to a shop and buy bangles, so in what quantity you buy bangles? So usually the quantity in which you measure your bangles will be dozens, right? Yes. So how much is 1 dozen of bangles? How many bangles you will get in 1 dozen? It is 12 bangles, right? 12 bangles. Okay. Yes, so how much will be 2 dozens then? 12 into 2, 24 bangles, right? So same way, if you're buying shoes, right? Will you go and buy just 1 shoe? No, it is a 1 pair of shoe, right? So 1 pair of shoe will be equal to 2 shoes, right? Yes. So same way, we are going to see how many particles will be there in 1 mole. See, 1 dozen will give you 12 bangles. 1 pair means 2 shoes. So we are going to see in the same way how many particles will be there in 1 mole. So let's see the definition of it. 1 mole is the amount of substance that contains as many particles as there in 12 gram of carbon-12 isotope. Yes, I repeat, 1 mole is the amount of substance that contains as many particles as there in 12 gram of carbon-12 isotope. So that means that 1 mole of any of your substance will contain as many particles are there in 12 gram of carbon-12 isotope. Okay, so how many particles will there be in 12 gram of carbon-12 isotope? Exactly the same number of particles will be there in 1 mole of your substance. Yes, so 1 mole is equal to this number. So that what I have told this 1 mole is 12 gram of carbon-12 isotope. How many particles are there? The number is 6.022 into 10 to the power 23 particles will be present. So what can you say? In 1 mole of any substance, there will be 6.022 into 10 to the power 23 particles. So this number is called as Avogadro's constant, or you can also call it as Avogadro's number, which is represented by the symbol Na. Yes, so this is Avogadro's number or Avogadro's constant. Instead of writing it as this long, you can just write it as Na. Yes, so what does this exactly mean? So let's say 1 mole of sodium atoms contains how many particles? Yes, 1 mole of sodium atoms contains how many particles? Or in 1 mole of sodium atoms, how many atoms are present? Yes, it will be 6.022 into 10 to the power 23 atoms. Right? So, in 1 mole of water molecule, how many particles will be there or how many molecules will be there? It will be again 6.022 into 10 to the power 23 molecules, right? Here water is a molecule. So, there it will contain 6.022 into 10 to the power 23 molecules, right? Now, let's take one more case. 1 mole of sodium chloride. Yes, this is an ionic compound. So, how many number of particles will be there in 1 mole of sodium chloride? It will be again 6.022 into 10 to the power 23 formula units. Yes, I hope you remember the formula mass that we had studied in last class. Yes, so it means that 1 mole of any substance, see, we took it in the case of atoms, molecules or ionic compounds, it will contain 6.022 into 10 to the power 23 particles. So, the particles can either be atoms, molecules or ions. Yes, I hope this part is clear for you. So, now we understood that in 1 mole of any substance, it contains 6.022 into 10 to the power 23 particles. Now, I am asking what will be the mass of 1 mole of your substance? The number of particles is clear, that is Avogadro number of particles will be present. But what will be the mass of 1 mole of any substance? So, that is your next concept, that is molar mass. Yes, from the name itself you can suggest what will be molar mass. It is the mass of 1 mole of a substance. Yes, so mass of 1 mole of a substance in grams is said to be molar mass. So basically it is equal to your atomic mass or molecular mass which is expressed in grams. Yes, molar mass in grams is numerically equal to atomic or molecular mass. So that means the molar mass, what will be the molar mass of water molecule? Yes, how do we find the molecular mass of water? It is 2 atoms of hydrogen and 1 atom of oxygen, right? So that is 18U, unified mass. Yes. So what will be the molar mass then? So the unit will be 18 gram, expressed in grams, right? Per mole. In 1 mole, how many grams it will be there? So 18 gram per mole. Clear? So let's take another case. Molar mass of, what will be the molar mass of sodium chloride? So what is molar mass? It is the mass of 1 mole of your substance. So molar mass of NaCl means what is the mass of 1 mole of your NaCl? That will be equal to, what is atomic mass of sodium? 23, and for chlorine it is 35.5, which will give you 58.5. So your molar mass will be 58.5 gram per mole. Yes. So I hope you are clear with what is molar mass. Yes. So in total, let us see in how many different ways you can express your 1 mole. Yes, it is based on what and all we have studied till now. So what is 1 mole in terms of Avogadro number? Yes, if it is represented in the terms of atoms, your 1 mole can contain Avogadro number of atoms. Right? 1 mole equal to 6.022 into 10 to the power 23 atoms, right? If it is in the form of atoms. Now, your 1 mole can also be equal to Avogadro number of molecules, right? Na molecules. Okay. So, this is in terms of number of particles that are present. Then we discussed about molar mass. Yes, so how can you represent 1 mole in terms of molar mass? Yes, 1 mole will be equal to 1 gram atomic mass. Now, what is this gram atomic mass? Yes, so it is the atomic mass expressed in grams, right? So 1 mole can be also equal to 1 gram atomic mass. Now, if it is in the case of molecules, how can I represent? Your 1 mole will be equal to 1 gram molecular mass. right? So it can be, if it is in the terms of atoms, it is 1 gram atomic mass. If it is in terms of molecules, it is 1 gram molecular mass. Clear? Yes. Now there is one more way which you can represent your 1 mole. If the substance that you have taken is in standard temperature and pressure conditions, that is, if it is in STP conditions, yes, your 1 mole of substance will contain 22.4 liter. Yes, so you can also represent it in the form of volume. This is only when the substance is taken in STP conditions, that is standard temperature and pressure. Yes, so I hope you are clear with this, in which and all way you can represent your 1 mole. This can be represented in the term of particles or also the masses and volume. Clear? Yes. So now let's see in which all way you can equate your number of moles when different datas are given, right? So if the weight is given in your question, how you can find the number of moles is given here. So that will be given mass by your molar mass. So let us say if the question asks you to find how many number of moles are there in 32 gram of any substance. So let us take 32 gram of methane. You have to find how many number of molecules are present. So how can you find it? The mass is given here. Yes, that is your given mass. N will be equal to 32 divided by, what is the molar mass? You know how to find the molar mass of CH4. It will be, yes, the atomic mass of carbon is 12 and for hydrogen it is 4. So that is 16 gram per mole, right? Yeah, so divided by 16, which will give you 2 moles, right? So I hope this part is clear. When the weight is given, you can simply calculate it in the way where given mass divided by molar mass will give you your number of moles. So let's take the example where you have to find the number of moles present in 3.022 into 10 to the power 23 molecules of urea. Yes, so the number of molecules is given here. You have to divide it by your 6.022 into 10 to the power 23. That is your Avogadro number, which will give you 0.5 moles, right? So what you have to do, if the number of atoms or molecules is given, you just have to divide the given number of atoms or molecules by your Avogadro number. Yes. Now, if volumes of gases at STP is given, what can you do? Yes, so the number of moles will be the given volume divided by 22.4 liter. We studied 1 mole of any substance under standard temperature and pressure conditions contains 22.4 liter, right? So the number of moles will be equal to the volume divided by 22.4. Yes, so these are the 3 ways in which you can use it in your numericals. Yes, clear. Now let's move on to our next topic, that is percentage composition. Now what is this percentage composition? So let us take the example of biryani. So how do you make biryani? There is rice, there is vegetables, there is meat, whatever you want to put, it all cooks together and you get your biryani, right? So in the whole of biryani, I want to know how much percentage of meat is present or how much percentage of rice is present. So how do I calculate the percentage of it? You see how much mass or how much amount of your rice is present compared to the total amount of the biryani there is present, right? So in the case in here, how do you find percentage composition? It is basically the mass of that element divided by molar mass of the compound. So in a compound, if you have to find out the percentage of any of the element present, so what will be the percentage composition of that element? It will be mass of that element divided by molar mass of the compound, the whole compound, multiplied by 100. Yes, so this is percentage composition. Now moving on to the next topic, empirical formula and molecular formula. Yes, molecular formula will be familiar for you. What is empirical formula? So let's see. It represents the simplest whole number ratio of various atoms present in a compound. Now, what is molecular formula then? It represents the exact number of different types of atoms present in a molecule of a compound. So, let us take an example here. Let us take the example of glucose. So, you know the molecular formula of glucose, it is C6H12O6. Yes, so this is the molecular formula for glucose, right? Now, what will be the empirical formula? See, it represents the simplest whole number ratio of various atoms present in the compound. See, there are 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen. What is the simplest ratio in which each of these atoms is present? It is 6:12:6, that is 1:2:1, right? Yes, this is the ratio. Now, what will be your empirical formula? Your empirical formula will be CH2O, right? Yes, the ratio is 1:2:1. So, your empirical formula will be CH2O. Clear? So, can I write it in this way? My empirical formula multiplied by some number will give you the molecular formula. Yes or no? So, in this case, what was the empirical formula? Is it CH2O? It is CH2O. Now, if I multiply it by the number 6, what would you get as your molecular formula? It will be C6H12O6, right? Which gives you the molecular formula of glucose. This was the empirical formula. You multiplied it by 6. In this case, it is 6. So, it gives you your molecular formula. So, in general, I can say your empirical formula multiplied by an N will give you your molecular formula. So, let's do a question based on this. So, you will get a much more clear idea of how to calculate your empirical and molecular formula. So, the question says a compound contains 4.07% of hydrogen, 24.27% carbon and 71.65% of chlorine. Its molar mass is 98.96 gram and you have to calculate the empirical and molecular formula for it. Okay, so the percentage is given in here. Yes, percentage of carbon is 24.27, percentage of hydrogen is 4.07 and percentage of chlorine is 71.65. So when you do the calculations or the questions regarding empirical and molecular formula, you can make a table like this, exactly like this. So it will be easy for you to calculate it. Okay, so first you have to write the elements here. Yes, and the percentage in this column. Now comes the atomic mass. We know the atomic mass of carbon is 12, atomic mass of hydrogen is 1 and atomic mass of chlorine is 35.5. Now you have to find the relative ratio. Now how do you find relative ratio? You have to divide your percentage by your atomic number. So what you have to do? It is 24.27 divided by 12, which will give you 2.02. This is the relative ratio in the case of carbon. Now in here you have to divide 4.07 by 1. 4.07 by 1 will give you 4.07 only. Yes. Now in the case of chlorine, it is 71.65 divided by 35.5, which will give you 2.01. Clear? So this is the third step that you have to do. Yes, you have to divide your percentage by atomic number, which will give you the relative ratio. Now, out of these 3 relative ratios, you have to find which is the least one. Yes, here it is 2.02, 4.07 and 2.01. This is the least valued number, 2.01. Now, what you have to do in the next step, that is the simple whole number ratio. For finding that, you have to divide the lesser number from each of this. That is, you have to divide 2.02 by 2.01, 4.07 divided by 2.01 and you have to divide 2.01 divided by 2.01. So this will give you 1, this will give you 2 and this will give you 1. Clear? So what did I do? The percentages were given. I wrote the atomic number. I found the relative ratio by dividing it. And from these 3, I have to find the value which is the least and divided by each of them, which will give you the simplest whole number ratio. So it is 1:2:1. So what is the simplest whole number ratio? Yes, it represents the simplest whole number ratio of various atoms present in a compound. What is that? Empirical formula, right? So we got the empirical formula here. The atoms present are carbon, hydrogen and chlorine. So what will be your empirical formula? It will be CH2Cl. Yes, clear? Now what is left to find in this question? You have to find the molecular formula. So just before we discussed how can you find the molecular formula? The empirical formula multiplied by some number will give you your molecular formula. Right? So in the question, what else is given? The molar mass is also given. So how can you calculate N? It will be the molar mass. What is molar mass? Molar mass is mass of 1 mole of substance. That is from the molecular formula, the mass that you can obtain divided by your empirical formula mass. So your N will be the molecular formula mass, that is molar mass itself, divided by empirical formula mass. So what is that? N is equal to, yes, the molar mass is given here 98.96. Now you have to divide it by the empirical formula mass. Empirical formula we already found it. Now it's simple to find out the molar mass of this. How do you find the molar mass of this? The atomic mass of carbon is 12, hydrogen is 2 and chlorine is 35.5, which will give you 49.5 gram per mole. So this will be your empirical formula mass, right? So what do you have to do? You have to divide it by 49.5, which will give you 2. So the value with which you have to multiply your empirical formula is 2. So yes, empirical formula, what it is, CH2Cl multiplied by 2 will give you your molecular formula. Now what it will be? C2H4Cl2. Yes, so this is your final answer. That is your molecular formula. Yes, from the table we were able to calculate our empirical formula. Yes, from there we calculated your empirical formula mass and the molecular formula mass was already given. You divided it, you found the N value and empirical formula multiplied by the N value will give your molecular formula. Yes, I hope it is clear. So in the next session, we will be discussing on stoichiometry, limiting reagent and reactions in solutions. So I hope in this class what and all we have discussed, it is clear for you. So that's all for today's class. Thank you.